I hope you're all enjoying DevOpsCon. I definitely am. It's been a great few days here, and I hope you will enjoy my presentation today. So first, a bit about me. I work at a company called Sys11. We are a managed cloud and Kubernetes provider based in Berlin. I've been working there since 2013. The company is 15 years old now, and our flagship product is called MetaKube. It's a managed Kubernetes platform where you can basically start and run a Kubernetes cluster in under 10 minutes. And we try to take away a bit of the complexity of Kubernetes. If you want to know anything more about this, we have a booth here at the event. So feel free to drop by and ask me any questions, or my colleagues as well that are here today. So my hobbies, anything related to Linux, tinkering with Raspberry Pis, building stuff, especially around K3s. I love K3s. It's like a great Kubernetes distribution, or everything built in one binary. If you've never seen it or used it, give it a try. It's like fun to do at home. And I also like doing cyclocross and long-distance gravel cycling. So I'm out on my bike a lot in the forest in Brandenburg and enjoy doing that as well. And if I'm not doing any of this, I spend a lot of time with my daughter, of course, as well. Okay. So let's go through the agenda and what you're going to hear today and what we're going to talk about. So number one, I would like to talk about the Kubernetes Secrets current situation, which has basically not really changed since Kubernetes was first released. We've been running Kubernetes at Sys11 now for roughly 5 years, and it's definitely one of the pain points if you're running and managing a large number of Kubernetes clusters for customers or also for your own use needs. It's a bit about securing secrets. So how can this be done? What methods are available to secure your secrets? And what options are there for managing secrets? So we'll go into this a bit as well and give you a few examples. Then I would like to talk about external secrets, KMS. Anyone use KMS currently for their secrets in Kubernetes or for managing stuff on cloud providers? Yeah, great. Definitely the way to go, if you ask me. And I'll tell you why later on. And towards the end, I would like to show you a demo, one, of course, opinionated demonstration on how you could solve these kind of problems, and a few ideas maybe, and a few takeaways for you, hopefully. Okay, so let's get going. What's the current situation of secrets in Kubernetes? So I'm talking about like a standard Kubernetes cluster, nothing modified. You create a secret from literal or from a YAML file, JSON, whatever you want to do. You send it to the API server. What happens? So at the end, this stuff is encoded in base 64. So anyone that's got a clue what base 64 is, you will all know, okay, this is no form of encryption. There are no keys involved. Anyone that accesses any of these files can read your secrets. So we're talking about your SSL certificates, and also, of course, your private keys that may be included, any tokens or arbitrary passwords that you may need within your application. All of these can be read. So this is definitely a big, big dangerous point, if you ask me, because it's definitely not anything that any security team are going to sign off, because it's definitely not okay. Also, this is also standard Kubernetes, so some cloud providers have modified the way they store data in etcd, but the standard way to store data in etcd is also unencrypted. So nothing is encrypted in the etcd. etcd is the key value store for Kubernetes. It's basically the database, the heart of Kubernetes. So in such, it's quite well protected. The only person or the only system that can actually access etcd directly is the API server. So none of the other controller components or control plane components can speak to the etcd. But normally people would also create snapshots of etcds. So where do you put these snapshots? Often, say, in an S3 bucket, somewhere else. These would also be unencrypted. Anyone could read these. So also something that you can look into. It is possible to encrypt secrets and also config maps in etcd. If you want to do this, you can find a lot of documentation in the official Kubernetes documentation. But standard, this is not done. Anyone that can create a pod can also read a secret in the same namespace in general. So this is also something that you need to be aware of, and this can definitely cause problems. Anyone with access to the API server can retrieve or modify a secret. So even worse, like you can actually change secrets that are there. You can even access the etcd and you could change them there. So what ways do we have to actually secure secrets within Kubernetes? So one of the ways would be to use RBAC. RBAC is the role-based access control, originally introduced by Red Hat. Didn't exist in the first versions of Kubernetes. This can definitely help to restrict what a user can do within the cluster, or also what a service account can do. So a service account is normally bound to a pod, and you can basically give them all rights if you wanted to, which a lot of people do, and I've seen this often when we do a lot of consulting and workshops with customers, and we often see this, that people just say, oh yeah, it's like a lot of stuff to do, so I just said, okay, I'm going to be cluster admin privileges. Yeah, not a good idea, don't do this. So you can definitely restrict the access by either cluster roles or roles. So roles would always be bound to one namespace. Cluster role, as the name suggests, is then cluster-wide privileges. The only thing that's a bit difficult about RBAC is you need to explicitly allow everything. So it's not like a deny. You can't say, okay, I just deny this. You actually have to allow every single resource. So this can be quite difficult, but there's like nice software around, like the RBAC manager from Fairwinds, which you can actually use to solve these sort of problems. You can restrict secret access to specific containers. So ensure that only certain containers running in your clusters can access secrets. Not all containers need to access the secrets. And you can also use encryption at rest for your etcd. So as I said just a minute ago, you can encrypt currently config maps and secret objects. What you should think about doing is the standard way that Kubernetes would do this is not very good. So the standard way would be you would have the encryption keys also on your API server. I mean, come on, every attacker is going to laugh about this, right? I mean, if he actually accesses your API server and he sees your encryption keys are on the same machine, that must be a joke. So, but you can get around this also with KMS systems. So KMS systems can have, you can have plugins into your API server. The encryption key can be in your KMS system. That is a lot more difficult then because the attacker has to attack your API server, gain access to the system, he finds the encrypted etcd, and then he has to gain access to your KMS system as well. So if this, you could either self-host this, which I'll go into in a minute, or you can do it with one of the hyperscalers. Or you can also use external secret stores. So you can store all of your secrets externally. And this would be also part of this talk and also part of the demo later on. So you basically decouple your Kubernetes cluster and its resources and your secrets. And this allows you to do a lot of things. So what options do you have currently for managing secrets? So option number one, both options I think are feasible. At the end of the day, you have to decide yourself which option basically works for you best. But I would say they're both good options or feasible options. So you can store your data encrypted in Git. That's possible. So just don't go and push your base64 secrets into Git, but maybe like consider like encoding them before you, or encrypting them, sorry. These can then be decrypted with sealed secrets in Kubernetes. So there's multiple ways of doing this. Two options which I would like to give you is Mozilla Subs and also Bitnami sealed secrets. Both have like a similar objective. There's normally like a controller running in your Kubernetes cluster, which then takes care of decrypting the secrets when they get injected into the API server. So Git, secret is encrypted. You then take, for instance, kubectl or some form of CI tool, Argo, whatever you're using. You then inject the secret into the API server. It sees the custom resource definition and knows, okay, this is a sealed secret. I need to decrypt this, and then I would make a normal secret out of it. This is also an option. But then again, you have an additional encryption keys that you need to manage. And it's all in the one cluster. So this would definitely be the disadvantage. It's definitely better than putting unencrypted secrets in Git, but I don't believe it's a perfect solution. I believe this is the better solution, storing a reference to a secret. So same situation, we've got a Git repository with our deployments, our services, everything we want to deploy, and let's say just for simplicity, Argo, we're using Argo as a continuous deployment tool, and we have a reference to our secret in Git. The secret is then created in the Kubernetes cluster on the deployment, and the values are then fetched from an external secret store. So this would typically be some form of KMS, so a key management system. So you can do this with all of the large cloud providers in general. So AWS offer a KMS system. Of course, you're going to have a certain vendor lock-in if you do this, but it's definitely a possibility. And it also takes away the burden of having to do this yourself and maybe securing this, updating this. So it does have like certain pros, but it always has certain cons. And if you want to move to another cloud provider, or you have like a multi-cloud strategy within your company, this could also maybe be difficult for you. The same on Google Cloud. They also offer a GKE KMS system, which you can use. Azure offer the Key Vault, and I think since about 2 months, HashiCorp Cloud Platform is also available on Azure. So they also offer you a managed vault. If you don't like any of these options, and you prefer to self-host, which we also do a lot at Sys11 as well, because we do work with some hyperscalers, but we do a lot ourselves on OpenStack. So of course we prefer to install open source software on our cloud. And a good option to do this would be HashiCorp Vault. You can self-host it. It's super easy to set up. You can set it up in VMs, or you can set it up in Kubernetes directly if you want to, which I've done here. I'll show you later on. And it basically does all the magic. It's super easy to handle. It's got like it works with the RAF protocol, similar to etcd, does its replication, and you can have multiple replicas of it, and your secrets are safe. It also has versioning and quite a lot of other things already included. So how can you then synchronize your external secrets? So we've got the secrets in the KMS into our Kubernetes cluster. So again, there's also multiple ways of doing this, and I'm going to focus on one. I just want to make sure that I give you a few ways of solving this problem. So there's like the Vault agent sidecar injector. It's quite a nice approach. What I don't really like about this, what I want to mention, is that you have to deploy the sidecar with your application. Similar to like Istio, which a lot of you are probably familiar with, you always have the deployment pods and then the sidecar on top of it. So you have to take care of two individual things which need to be deployed together. I find this a bit of a burden. Can work for you. So if it does, then good. But otherwise, it wouldn't necessarily be my favorite way of solving this. Argo CD, if you're using Argo, then there's a Vault plugin, which allows you to directly reference secrets and read them from HashiCorp Vault. And on deployment, you get your secret objects within the cluster. Everything is available, and you can use them. Initially, I built this talk around the external secrets operator, which is a really great tool. I actually spoke to 2 of the developers at KubeCon, and really interesting. There's one reason why I actually decided not to do this, but to build the talk around the secret store CSI driver. I'll go into this later. One of the things I liked is that it's a Kubernetes SIG project, so it's like one of these special interest groups. So it's basically got a very high chance of actually being taken forward and having enough people working on this project, which I think is interesting. I also like the idea that they actually use the CSI, so the container storage interface, to do this. And I'll tell you a bit why in a minute, what's actually great about it. So secrets store CSI driver. As I said at the beginning, like this is an opinionated talk, so there's definitely all of these other ways of solving this. I just chose this way, and it doesn't mean any of the other software is in any way worse or better than this. So you can sync with Kubernetes secrets. You can mount secrets to a pod using a CSI volume. That was actually one of the key features why I chose to use this software. It's one of the features I really like because when you create the secret, it basically creates a tempfs volume and it writes the secret to the tempfs volume. A lot of you can probably already imagine why this is so good, because you're not actually writing a Kubernetes secret. So that means the secret is not going to etcd. It's on a volume. It, of course, has one downside. You need to build your application in a way that you can read the secret that you need from this volume. So if you're building your own applications, this should be fairly simple. If you're maybe using like standard applications like WordPress, this might not work out of the box because it would normally rely on environment variables or on a standard secrets which are mounted as environment variables. So you can also mount multiple secrets. So if you need multiple secrets, you can also store them all in one volume, which is also helpful. A lot of applications don't just require maybe a database password, but there's also other things involved they may need. And there's also multiple external secrets providers. So you can use all of the KMS systems that I spoke about in the previous slides. They all work, and I think they're going to add additional ones afterwards. So there should be an option there for everyone, which is valid and works. And you also have Linux and Windows container support. So if any of you are running Windows containers, this is also possible. It's also fully supported. Also a nice feature. And one of the most important things for compliancy teams and security is definitely secret rotation. You can, with a majority of software, you can do the automatic secret rotation. I'll show you this in the demo. This definitely helps when you're on and offboarding members of staff. People are changing teams depending on the size of your company. Some people have like compliance teams that say, okay, you have to rotate or change your secrets every X months or something. This definitely makes it a lot more easier to get this job done. And it does make sense to do this as well. Also, don't use your secrets across multiple environments either if you don't have to. There may be like certain things that can be feasible, a pull secret for a registry or something, but always remember, often the development systems are not as well protected as the production systems hopefully are. And once someone can access secrets that you're using across all environments, it also means that you've got a large security breach. Okay, so how does the secret store CSI driver work? So basically on the left-hand side, we have a kubelet, which is installed on every node. So the box around the outside would be a compute node. We have a kubelet. It basically schedules a pod for us. Well, the schedules the pod, but the kubelet starts the pod. We have then a custom resource definition involved with a secret store CSI driver. It speaks to the secret store CSI provider via gRPC. Then we have typically a service account, which is mounted into our pod. And this service account can then be used to authenticate against Vault. As I said, in this example, I'm using Vault. This might be different with other KMS providers, but in Vault, you can use Kubernetes authentication with service accounts. We retrieve the secret. The secret store CSI provider gets the secret, and then we write it to our application, to the pod in our tempfs volume. The tempfs volume is then mounted into the pod, and the pod can then read the data, hopefully. So this is basically how it works. To get everything up and running and the demo running, I did a bit of preparation. I just want to quickly walk you through what I've actually done. So I've got a lab cluster up and running, which I'll show you in a minute. And there's some Kubernetes configuration. So we have an Nginx ingress controller running. The ingress controller has a load balancer service in front of it with a public IP, so we can access our application. We have Cert Manager from Jetstack. That basically does our certificate. Hopefully it works, and then I can show you that it's also got TLS encryption, the application. We have external DNS external DNS, if you're not familiar with it, basically looks at my ingress rules. If I create a new ingress rule, it basically adds the host name to my DNS. So I'm using Route 53 to do this, but you can use like multiple DNS providers which are supported, and mostly anything that's got an API. So you're going to need some form of API and an API token. And we're using HashiCorp Vault with CSI secrets enabled. Okay, and then a small Golang application I built. No, I didn't actually, I lied. ChatGPT actually built it for me, which worked really well, surprisingly. So I built 2 applications with ChatGPT. Thought I'd give it a try. And next, we're using Vault. So in this case, I installed Vault in the cluster just for simplicity reasons. I would not recommend doing this. I would definitely recommend either having, if you've got multiple Kubernetes clusters, either running an out-of-bands cluster, a service cluster, whatever you want to call it, where you maybe have certain tools, so you can separate, decouple these, or, as I mentioned earlier, use one of the cloud provider services. Could be easier for you. Just means that you kind of got like maybe a bit of login or maybe a bit more money to pay, but sometimes this can pay off long term over like total cost of ownership and things like this. So I configured Vault with the Terraform provider. So HashiCorp offer a Terraform provider to configure Vault, which is really nice. So I did all the configuration with that. Then I set up the Kubernetes authentication, also with Terraform. So my Kubernetes cluster can authenticate against Vault. This is typically done with a SSL client certificate. And also, of course, you tell Vault from which IP. So normally your load balancer, if you have a multi-control plane set up, that it knows which IP it's going to connect. And then there's an auth role, which then maps to my service account in a certain namespace where my application is running. And last but not least, we have a policy to access the secret. Okay, let's go into a demo and I can show you how all this works. So bear with me and I will try and show you. If this is not big enough, then just let me know. Then is this big enough? Can everyone see? Okay. So, okay. So first off, we have a Kubernetes cluster running with a few compute nodes. And in this cluster, we have a few namespaces. So as I mentioned earlier, we have like the cert manager, external DNS, and also our ingress. And if we quickly look at our ingress, we will see the ingress has a service, which is a service type load balancer, as many of you are probably familiar with. And this external IP basically points into our cluster and is the way that you can publish multiple applications. What we're going to do now is basically create the certificate or anything. But before I do this, I will quickly show you the Vault server. Okay, yeah, so you can see this now. So in Vault, one of the important things that you need to activate to get this done is the authentication method Kubernetes. So there's, as I said, there's multiple ways of doing this. And there's a service account here, as you can see. The service account is called Web App SA, so this belongs to our web application. I have 2 different authentication methods, and they're bound to a namespace deploy env and deploy volume. And at the bottom, they also have a policy. My policy is like not really strict. You could do really strict policies, so I'll quickly show you the policies. So I have this policy reader. In Vault, you can basically create policies. They can be super strict. They can be like tied to one secret if you want to, so you can ensure that a pod can only read exactly that secret. That should be the way to do it in production. I just like put an asterisk here, a wildcard, so I can read any secrets under K8s, which made it easier to set up. Don't do this in production. Not a good idea. And we have a secret here. So if we look in here, you will see that there is my web app, and our secret is DevOpsCon. So hopefully, if everything works out, we should be able to retrieve this secret with our application from Vault. Okay, let's see if we can get this working. So first off, I would start and deploy the CSI driver. So I'm going to use Helm to do this. And I have a few values which I can show you in a moment why I've done this. I'll just quickly install it. This will basically set up a daemon set with the CSI secret store driver. So a daemon set, you need a daemon set so it runs on every single node that we're working on. So yep, this is installed. I'll quickly show you. I made only a few minor modifications, so I basically don't want it on any of the storage nodes. That's why I have this like anti-affinity rule. I also enabled the secret rotation. This is currently still an alpha feature, but it's going to be released as a beta feature and also a stable feature very shortly. So I've been told. Maybe this is already the case. I didn't check. There's been a new release, but I was away on holiday for a while, so I haven't checked this yet. And I also decreased the rotation pole interval. You probably won't need to do this normally. You could probably leave it on something like 5 minutes, but waiting here for 5 minutes would probably feel like a long time for me if I was like sitting here just to see if the password rotation works. That's why I decided to change this too. Okay, so let's see what we've got then. So we should have a namespace called CSI Secret Store. And in there, we should have a pod. If we check, this should be running on all of our worker nodes, but not, as I said, also on our master or control plane nodes. It's not running on the storage nodes because I don't need it there. And if we have a look, we should see that there should be the logs. We can check one and see that it's basically started and it's initialized. It's there. And we also should see that we have a CRD. So a quick look, see if this is the case. We should have 2 CRDs. So CRDs are basically, if anyone's not familiar with CRDs, it's basically like an extension to your Kubernetes cluster. So like a plugin or something that you've installed additionally, you can imagine like this. So now we have like a new command. So we can now say, show me secret provider classes or show me secret provider class pod statuses. This is like new, and as you can see on the right-hand side, it's just been installed. So I'm just going to glass of water. So we can now use these, and we can now use these new API versions. So this is basically what a CRD does. A lot of applications bring CRDs with them, which are kind of helpful. They only basically have one large trade-off. If you would like to install multiple versions of software because you're testing it, this is in general not possible with CRDs because you cannot install multiple versions of the same CRD into one cluster. There are nice ways of getting around this. One of them would be a really nice software by Loft called Virtual Cluster, in case you're interested in doing something like this. If you're a software developer, this may be interesting. Instead of like firing up a cluster for every single version that you need to run. Okay, so now next I'm just going to quickly deploy this application, and then I'll show you, because this is going to take a while for everything to come up and get running. So I'll just do this first, and then I'll show you what I'm actually deploying. I'm just going to deploy both applications, because in the background, they're going to do all the external DNS magic, hopefully. They're going to do the cert manager stuff. They're going to create a certificate for us. This is going to take a few minutes. So while this is running, I'll quickly show you what I'm doing. So number one is the deployment environment. So this would be a simple version of the deployment. You can see first at the top, I create a namespace. Then we have the service account. If you remember that I showed you in Vault, you can see it's called like web app SA in the namespace deployment env. And this is the deployment that probably the majority of you are familiar with. If you look further down, then we can see one of the things that I'm doing here is I am writing out the web app secret to the environment. So there's like a secret key reference, as you would do with a normal secret as well. It's called web app secret, and our key is password. So this is exactly what we saw in Vault. Additionally, I'm also mounting this secret to MNT secret store. So we also have a volume mount, and somewhere underneath, we should also have a volume. So at the bottom, you can see This is basically a CSI. So this is basically the only difference in normal secrets. I'm speaking to a driver, secret store CSI k8s.io. It's a read-only true, so no one can modify this volume or the secret within it. And we're referencing a secret provider class called deployment-env. And another thing which is definitely also good practice that I can definitely give you, which I see a lot of people do wrong. You can see my pod is running on port 8080, but we can still speak via the service to my pod on port 80. What does this mean? We don't need to run our pod as root. So that my pod can run as any user because it's running on a high port. So any port higher than 1024 is good. Do not try and use any of these low ports to start pods. Unless you have to for some reason, which used to be for a while Istio, but even that, you don't need to do that anymore. So if people tell you to run pods as root, privileged, do not do this. It's not a good idea. Okay, so next up. So I also deployed an ingress. I'm not going to go into this. I think the majority of you probably know what an ingress is. An ingress is like the Kubernetes version of virtual hosts. It's just basically a domain and a path and tells me how to get there. The new thing is the secret store. So we have a new a new API version, which is secret store CSI, exactly the same as the CRD I showed you, and the kind is secret provider class. When one of the secret store CSI drivers sees this, it knows it has to do something. In this, we reference the data, so the key password again, the object name, web app password, which we saw in Vault. We are using a secret name, and we're also using the Vault address. And in this one, you will see that you can see the Vault address is vault.metacube.org and the role name deployment-env. And if you do this, it will also create the secret name web app secret. So let's check if it's done this and have a look. One thing I actually forgot to show you is also that we now have a new CSI driver. Oops. CSI driver, of course. So you're probably familiar with something like this. Like if you run one of the cloud providers, you might have something like a Ceph or a Cinder driver. This is a new one we just installed. So 6 minutes ago, we installed the secret store CSI driver, which is an ephemeral driver, which basically the secret store CSI pods, they communicate with this driver and create the tempfs volumes. Okay, so let's go and have a look at our first application. So deployment-env, we said. So we should have a pod running. Yeah, we have a pod. And we should have a secret. Okay, so first, let's have a look and see if we can decode this secret. So what you can do in Kubernetes is you can read a secret. So I'm reading the secret in deployment-env. I'm outputting it as a JSON path, and the data included is data.password, and I'm just sending it to base64 decode. So this should be DevOpsCon, as you can see. Yeah, this is the correct password. It's DevOpsCon. And in this case, we also should have a volume in the cluster. So we said that we're going to mount this to MNT secret store web app path. So let's have a look if this is also the case. Yep. So we also have the password stored on the volume. So I just set a cat to the volume. The file is called web app path. We can also read it there. And if everything is going right, we should have an environment as well. Yes?
Two commands above, they will get secrets. So this means it is present in etcd.
Yes, in this version, this is present in etcd. This is the first version of our application. And in the first version, I said, okay, we're going to say we're using a standard WordPress or anything that needs this secret, requires this. This is definitely an option that you can do. I don't think it's a perfect option. That's why I wanted to show you in the second version of my application that this can also be done differently. And if you're under control of your application, this should be a good option for you. And you can also see that next a few other variables. So Kubernetes always injects into the pods. So it always tells you like where the Kubernetes services is and a few other things. You can see my secret is also included here. Because at the top, we said that we wanted to create the secret, and in the deployment, we basically said we wanted to create the environment as well here. So we basically wrote this out. We have everything there. So we definitely already have our secrets encrypted, but as you already said, this is definitely still going to etcd. So you would find this information in etcd.
Can I ask a follow-up question?
Yeah.
I'm confused. So this means from the application end, there is basically no change regarding referencing the secret, only that you have to add the additional volume, right? At this point.
Yes, yes, exactly. So from the application perspective, this is completely transparent. There's nothing has changed here. That's why it can be a valid option for people that are using like arbitrary applications, which they can't modify that easy. You're using like a stock WordPress, then it will probably be a bit more difficult if you wanted to read the volume from a volume at the beginning. So you could just use a standard way, you've got the environment, nothing changes for you. But you still got the additional security because you've got like you've decoupled your secrets, and you've also got these rotation options as well. Okay, so next up, I would like to show you the, all right, so I'll go to the YAML first. Let's have a look at the second version of the application. So the second version is basically got the volume mount. It's got no form of environment here, but it's got the same volume mount. And it's also got the same volume underneath. It's got the service account, everything is the same, but I'm not writing out any data to the environment. If we have a look at the secret store, it's also there. As you can see, it's a bit shorter than the previous version. The only thing we do here is we read exactly the same secret, but we only write it to the volume. There's no environment, there's no secret, there's nothing else included, no reference, so you won't get a secret. So this means, as we already said, that this won't be written to etcd, which I think is a great improvement. If we have a look here, you can see in our volume namespace of our second application, the only thing which is there is a TLS certificate. There's no secret. And if we have a look, you should also be able to see that it's... Let's have a look. On the volume, and also the same password is there. So, but you won't see anything in the environment. So we can quickly check this, just to make sure that you believe me. And you can see this is basically empty, there's no password included. And if everything works, we should be able to see this on the web too. So application number 1, yep, DevOpsCon, and application number 2, let's hope the privacy error goes away, yep, DevOpsCon. Okay, so next up, let's go and try and rotate our password. So let's go to Vault. This could be done by API. I'm just doing this via the UI just to make it a bit more transparent so everyone can see what's going on. Normally you would probably do this with some form of automation. So, as I said, you can see Vault has a versioning built in, so I could go back to any of the last versions, which I also think is a great feature. You can set this how you want it, so you can also configure it to only keep a certain amount of versions. So let's just update our password and make it new. And we should see in a few seconds that this will get to our applications. So what do you think is going to happen on application number 1, which is mounted the secret? Do you think we're going to see any changes here? No, absolutely right. We've mounted a static secret into the pod. This is not going to work. Application number 2 should see this shortly. Application number 2, of course, that I built, don't do this in production because you can probably already imagine what you can do here. Nasty. Let's go back to our password, and now we see the password has been updated. So in the background, the controller has noticed that the password has been modified due to the sync policy of 1 minute. It's checked, seen the passwords change, and it's written it back to the volume. So if we look here, then we will also see the same would be reflected on the shell. If we change this, and on application number 1, this should also be there on a volume, but the environment does not know anything about this. Sorry. Yep. So our environment does not know anything about this, and the volume should know about this though. So if we have a look at the volume itself, the password will be there and will be changed, but the only way we could actually change this would be if we say go and we do a rollout restart of the deployment. Then we will see our pod should be restarted in the background, which can be feasible for you. There's a new pod being started, so our service is not offline. When this pod comes back up, we should see that the password is also reflected and should also change now. Yeah, here it is. The password is also changed here. But you still have this additional work to do. And, of course, the downside that your password is still in your etcd. But depending on what methods you use, I definitely think they're both great improvements over the standard methods that you will find in Kubernetes. So it's definitely extremely helpful, but it's definitely not the best way of solving this problem. So, yes?
Maybe I didn't pay attention. How was the pod redeployed to fetch the new secret?
I basically did a deployment rollout restart.
Manually.
Yes, so there's multiple ways of doing this. So you could basically, if you were doing with Argo or something, you could change a label or something on the pod, which would also force a restart. But in some way, you have to enforce that the secret gets mounted again.
Is there a best practice to do it? I mean, Vault rotates the secret, and then the operator knows it has changed.
Yeah, and this
Hooked somewhere?
in my situation, of course, is a really simple situation, a really simple scenario. Often it could be that there's multiple things involved in this, because you might have like databases, key value stores, and other things, and you need to do it at the same time. Otherwise, it's not going to work. So one of the ways would be a lot of people like add like timestamps as labels to their pods, which forces a restart. Of course, all of this depends on having multiple replicas of all of your deployments. With databases, this can be even more complex, depending if you're running your database in Kubernetes or not. This could also mean that you're going to have some form of failover or something from your primary to secondary. So in my scenario, this is fairly simple. We have like one pod consuming one password, but in production, this can be a lot more difficult depending on what you're doing. Hopefully, it shouldn't require a maintenance window. I would say no, but it could do. Okay, so thank you very much for your attention. And if you have any questions, please feel free to drop by our booth. There's 3 colleagues of mine here sitting in the back row, Patrick, Johannes, and Christian. So drop by and ask us any questions if you're interested in managed Kubernetes, OpenStack, or anything else. If you're interested in asking me any questions, then I will definitely stay here for a few minutes. Or of course, I can take the questions now. Yep.
I have actually 2 questions. Just one for the clarification. What changed in the application logic now between application 1 and 2? Because the one loads it from the environment, the other one accesses the file in the mounted volume, right?
Yes,
okay.
That's basically the big difference. So I built the second application in a way that the secret could always be retrieved, and you could do this yourself. You could like have like a retrieval that basically notices that this volume is changed. Would be an option. You could just have a look at it every 60 seconds or something. Whatever is basically works for you.
Thank you. And the second question was, you mentioned in the talk that you prepared this presentation around the CSI vault and not around security operators?
Around this external secret operators, what I was first using, and then a colleague actually told me while I was like holding a similar presentation in my company, hey, have you seen this software? And I said, oh yeah, have a look at it. And as the majority of you know, cloud native is a full-time job, so I sat down, had a look at the other piece of software and thought, okay, this definitely has a few features that I really like.
But what were the drawbacks? Because you mentioned you wouldn't choose the security operator And you said you would mention some reason why you didn't.
The reason why was basically the volume. So you can write it to a temp FS volume was basically the reason why I decided to choose this, because I kind of like this. I like the way that it wasn't being written to etcd. Okay. That was basically the takeaway. But both are definitely valid options, so there's nothing wrong. And if you're encrypting your etcd anyway, then it shouldn't make much of a difference to you.
Thank you.
Any other questions?
When using the sidecar solution, there is the Vault agent, and it has a kind of command to trigger the restart to inform the application that there are new secrets available. Yep. Is there such a trigger here in this solution as well?
No.
Okay.
That's definitely one of the big advantages about Vault. It doesn't work with every type of application, but it works for the majority, that you can basically use this rotation and the sidecar can trigger the change into your pod, with the disadvantage, of course, that you need to install a sidecar with every single pod. So this can, of course, be a resource point, that you have like more resources. I don't think it's going to cost you that much. But if you think like, okay, you're running like Istio, you're running sidecars for passwords, you're running exporters, then it just gets more and more. And you also have to take care of updating these individually. And every time you update a sidecar, you need to update your main application, or you need to restart your main application. Otherwise, it's not going to work. So I always think that this can be a bit of a pain. It doesn't have to be. So that's why I said like I wanted to show you like multiple options that you have to solve this problem.
A follow-up question to the question from the guy for production, the Vault Secrets operator versus the CSI thing you just showed, which has seen more production usage, which is more stable. So which would you pick if you could just one or two?
So if you're encrypting your etcd and this is not an issue for you, I think I would probably go with the external secrets operator, because it's been around a lot longer, and the CSI driver is currently some of the parts. Definitely like the rotation I showed you is still on alpha, and I'm not sure if I really want to use alpha software. I mean, in Kubernetes we kind of got used to using beta software in production, but alpha seems like a bit too much. But I think it's going to evolve very quickly, and because it's like a SIG group, it's got like a very high chance of being maintained and being enough people evolving it.
So it's new, but it's a bit more standardized.
Yeah, it's a bit more standardized. I always like SIG projects because I think, okay, you can join the SIG groups, you can participate, and there's always a lot of things happening around them. Whereas some other projects, especially if they've only got 30 developers on them or something, I'm always a bit skeptical. How is this gonna work? If it's just like one company behind it, it works sometimes. I mean, Jetstack Cert Manager is a good example, but it doesn't always work. You had another question?
Yeah, that's related to that one. So what made you trust the security operator? Because operators are these black boxes that do stuff, right? And that one does pretty interesting stuff. So what made you trust it?
Basically, multiple things I would say. They have like an open Slack channel and also a SIG group which you can join. You can speak to the developers. I got in touch with a few of them at KubeCon. All of the issues that they were targeting and the way it was coded, I had a quick look at the code as well, seemed like to me to be a really good project. And yeah, there was a lot of people on the project already, which doesn't generally mean that it's good, but it definitely gives me a lot more confidence in using something if I see like there's a couple of hundred people working on it, distributed across different companies, versus like one company working on it.
We also have one question from the live chat from Patrick. How a mounted secret volume gets consumed by the app too? You basically need to build something in your application to consume this. So you can mount the volume into your application, but it definitely doesn't mean that your application is automatically going to consume it. Your application needs to be built in a way that it retrieves the secret from there. So that would be the answer. Okay, thank you very much for your time.